Hello world, I am Rohit and this is the project 0B Tic Tac Toe of CS50 AI, in which we will be implementing the well-known game of Tic Tac Toe using the Minimax algorithm. This project needs us to implement these 7 functions, and I will be explaining each of them as we implement them in the code. And before getting into the actual code, just a small note that we do not support any kind of plagiarism and do not just copy paste the code. I highly recommend trying it first by yourself and then seeing the solution for help. So here we are in VS Code and I have already downloaded the distribution code from the link provided here. And so let's us implement the first function, which is the player function. What it does is it takes the initial game state and returns the next move for the player, and it will put up any return value if the board is a terminal board state, that is the game is already over. So let us implement the function. So let us first remove the not implemented error. Now what we need to do is count the number of X and O in the board, which we take input to the function, as we can see here. So let us do that. Count. We will be using the sum and the count function to count the number of X's and O's for a row in the board. So let us type it. So what it does is it counts the number of X's for each row in the board and adds them together to get the total number of X's in the whole board. So let us do the same for the O. So we have done this correctly to count the number of X's and O's in the board. Now what we need to do is return the player whose turn is next. In other words, return the player with the lower count of the symbols. So what we need to do is, what is the logic behind this function is, if the number of X is greater than the number of O's, so we return O. If not, we return X. This is the simple logic here. So we have successfully implemented the player function. Next we will be implementing the actions function. What it does is it takes the board as input, which is the state, and it returns a tuple as output representing the possible action that can be taken on a given board. So let us implement the function. First we will remove the not implemented error, and first of all we need to check which of the spots in the board are empty, for which we will use the for loop. We will be using a nested loop using two for loops to check every cell if it is empty or not. So let us implement this. We have passed 3 in the range function because the tic-tac-toe game is a 3 by 3 cell game. So now we will checking if the cell is empty. If board I j is empty, what we need to do is add them to some list or set for us to return from this function. So what we need to declare is possibly a set. So let us do that first. I will name it possible actions is a set. Now we'll add the empty cell to the possible action set. Using the add function. And return the possible actions. And now we have implemented the actions function. Now let us implement the results function. The result function takes board and actions as input, and it returns a new board state after inserting the action, which is the player's move. So if the board is not valid, we need to raise an exception, and we need to make a deep copy of the board so that the original board be left unmodified for the minimax function. So let us get into the function implementation. We'll first remove the not implemented error. So our first objective is, if the move is invalid, we need to raise an exception. So what we need to check is if the action is available in the board for the user. So if not action in actions board actions, which is the previous function we have implemented, what we do is we raise an exception. Stating invalid action. Invalid action. Now we will make a deep copy of the board. So copy board equal to copy dot deep copy, which is a function from the copy library. We'll do deep copy of board. Now what we need to do is we need to insert the user's move, or here in case our action. So for that we need to do is copy board. We need to get the cell from the actions. Action 0 represents the row of the board, and action 1 will represent the specific cell or the column of the board. We'll insert the player dot board. As this function returns the player whose turn it is. Now we'll simply return the copy board. Now we have implemented the results function successfully. Next we'll implement the winner function, which takes a board as input and returns the winner of the board if there is one. One can win the game with 3 of their moves in a row horizontally, vertically or diagonally. So in the tic tac toe, what happens is if a player gets 3 in a row or 3 vertically or 3 diagonally, the player wins. If there is no winner, we should return run. So let us implement the function. First we will remove the not implemented error. First we will check the rows horizontally. For which we will use a for loop. Now what we need to do is we need to check if in a row the count of the symbol either X or O is equal to 3. We'll be using the count function. So let's do it. I represents the row here. Will return X. And if the symbol is O, we will return O. Now we have checked the board horizontally for a winner. Now let us check the diagonals. For checking the diagonals, what we need to do is we need to check each of the diagonal cells and check for the symbol. So first we will check the left leading diagonal, for which we need 3 cells which are 0 0, 1 1 and 2 2. So what we did here is we checked if the diagonal cells 0 0, 1 1 and 2 2 are equal to one another and are not empty. If they are not empty, we will return one of the cells. Here in case I chose 0 0 for simplicity. Here we will do the same for the right leaning diagonal. For the right leading diagonals, the cells are 0 2, 1 1 and 2 0. Now we have checked the board horizontally and diagonally. Now let's check it vertically. We'll check this vertically using a for loop. So let's do it. We need to assign a variable, initialize a variable to count the number of X's and O's. Now what we need to do is we need to check in each column if there are 3 X's or O's, for which we need to use another loop. We will be using a for loop. and checking the rows. So what we did here is we check the first cell of each row which constitutes a column, and if the count is equal to 3, we can return the winner, which is either X or O. So now we have successfully implemented the objectives of checking the board horizontally, diagonally, and as well as vertically. Now if there is no winner for the given board, we return none. So I think we have completely implemented the winner function and checked the board horizontally, diagonally, and vertically. Now we will implement the terminal function, which takes a board as input and returns a boolean value either true or false, indicating whether the game is over. So let us implement the terminal function. First we will remove the not implemented error as usual. First we need to check if there is a winner of the board as we implemented the previous function. So if there is a winner of a board, of the given board, will return true. Next, what we need to check is if any of the cells in the game, in the board of the game, is empty or not. If the cell is empty, if any of the cell is empty, will return false, and if none of the cells are empty, will return true. So to implement it, we'll need a loop, a nested loop. If any of the cells of the board is empty, will return false. If board row, which is represented by I, and J, which represents the column, is equal to empty, will return false. Now we will return true. I think we have successfully implemented the terminal board function. Now we'll implement the utility function. So let's see. So the utility function should accept a terminal board as input and output the utility of the board. So if X has won the game, the utility should return 1, and if O has won the game, it will return -1, and if the game ended in a tie, it will return 0 as of the value. So it will be the easiest function we implement in this project. So let us do it quickly. We'll remove the race implemented error and we'll store the value of the winner function in a variable. Now we'll check who is the winner. Now if the winner is X, will return 1. Else if the winner is O, will return -1. If winner equal to O, return -1. Else will return 0. So I think we have correctly implemented the utility board function. Now we need to implement the minimax function, which is the last function we need to implement. So let us see what is in there. The minimax function should take a board as input and return the optimal move for the player to move on the board. The move returned should be an optimal action I and j in form of I and j, that is one of the allowable actions on the board. If the board is a terminal board, the minimax function should return run. So for this function we'll follow the algorithm demonstrated in the lecture, and we'll borrow some pseudocode from there. So here is a lecture slide which states the minimax function, and here is some pseudocode for it. So we'll try to implement in our Python code. For it we need to implement two different functions, namely max value and another is min value function. So let us do it. Def max value, and first we need to check if the board is a terminal board. So if the board is a terminal board, we return the utility of the board, and then we assign a value to -infinity for the max value function. To assign -infinity, here I am using the math function. You can also use the float function available in the Python. Now we will implement the main objective of the max value function, which chooses the maximum value among the minimum values provided by the min value function as given here in the algorithm, and will return the maximum value among the minimum values returned by the min value function. So let us implement the logic. We'll be using a for loop for checking all the actions available in the actions.board, which is a function that returns all the possible actions which we have already implemented. So let's do it. Now we need to get the minimum value from the min value function. So the min value function, we have not implemented it yet, but we'll implement it shortly. It will have the same structure as our max value function, and we'll call now results function. What the result function does is it returns the board after action is taken. Now we need to assign the maximum value from all the values we get from the min value function. For it, we'll do is if min value is greater than v, we will assign the value to it. V equal min value, and the function also requires us to return the best function, and the function also require us to return the best action, which is here. So we'll also need to return the actions. So what we'll do is we'll create a new variable, best action equal to action, and we'll return v, which is the maximum value among the values provided by the min value function. I think we need to initialize the best action value first. We'll also need to return a none if the board is a terminal board, because we are returning two values if the board is not a terminal board, as you can see here. So we'll do return utility board, and because there is no best action available. Now I think we have successfully implemented the max value function given the algorithm in the lecture slide, as you can see here. Now we'll do the same for the min value function. We can just copy and paste and change some of the variables. So let us do it. We'll change the name to min value. It will be the same. If the terminal board is reached, we'll return utility board, and there is no best option, so we'll return none. We'll change the we'll change v to plus infinity, not minus infinity for this case. We'll assign the best action to none, and here we'll need to find the minimum value among the values returned by the max value function. So here we will type max value, and call the max value function. We'll make a small change here, like if the max value is less than v, which is at first positive infinity, then we'll assign the value of v to the minimum to the maximum value. Best action will remain the same, and will return v and best action. I think the code is correct. I think we need to fix a small bug, which is, as we are returning two values in the max value function as well as the min value function, as you can see, we need to insert a dummy variable. So we can just put underscore here, and we need to do the same here also. Now I think we have implemented the min value function correctly. Just adding comments to the functions for us to understand. So at last we will be calling the min value and the max value functions in the minimax function, which is a given function from the distribution code. So what we need to implement in this function is we need to take a board as input and return the optimal move or the best move for our case for the player to move on that board. The move returned should be the optimal action, that is one of the allowable actions on the board, and if the board is a terminal board, the function should return none. So it will be fairly easy to implement. So let us do it. We will remove the not implemented error, and if the board is a terminal board, we return none. And now we need to return the optimal action for the current player on the board, for which we need to assign the min value or the max value function to a specific player, which is either X or O. So let us assign the max value player to X. So if the player is X, we need to return the optimal action by calling the max value function, which we have implemented right above here, right here. So we'll use the if statement. So what we did here is we got the player from the players function, which we have implemented earlier, and we have called the max value function, and we have used two variables, which one of them is a dummy variable, because we do not need the v, which simply returns the value, which we do not need in this case. We'll do the same for the O player, which is the min player. So we'll do the same for the min value player, which is O. So now we have called both the players. We have assigned the max player to X and the min player to O. Now we'll return the optimal action based on the player which we get. So return optimal action. I think we have successfully implemented the Minimax algorithm in the Minimax function here in Python. So there were some bugs in our code. In here we did copy board equal to copy.deepcopy from the copies library, but we have not implemented the copy library. So we will do import the copy library, import copy, and in the max value and min value functions, here we have previously not inputted any parameters to the function, so we have inputted board, and in the min value function we have also inputted the board. There was another bug right here which says if the max value is greater than v, which will be always false for the first case, as we have assigned v to plus infinity. So we'll just do max value is less than, if the max value is less than v, we assign the value of v to the max value, the value of the max value variable. Now let us run the check 50. As you can see, we have passed all the test cases, and hence we have completely implemented all the parts of our program correctly. You can go right ahead and submit it through the submit 50 command. And if this video helped you, you can put a like and comment for feedback. Thank you. And this was project 0B Tic Tac Toe of CS50 AI.